Okay, in this video we are going to reassemble the Ma4-5 carburetor. I've got my manual out, all my parts. You should have inspected, cleaned, and replaced any parts that were out of tolerance or otherwise damaged or broken. So this carburetor has not been cleaned up. It's in okay shape, but for demonstration purposes, it'll be fine, showing you how it all goes back together. So the first few steps under the assembly procedure talk about reinstalling the throttle bushings, which we kind of showed roughly off camera, the basic tool, how to remove and reinstall. Now there is more to that, and they kind of show it in all these diagrams here, how if you need to, you can remount the holes for the bushings there to get them realigned. How to install the inner packings and O-rings, which is a delicate process of getting those in without damaging them. Talks about all that. And even continues on the next page, how to check them for leaks. Since we did not remove the bushings from this carburetor, we are going to skip that step. But I will note here, because I think it's important, special test procedures. So let's look at that. Says 48 leaking packings can upset the carburetor's metering characteristics and affect fuel management. Yeah, the throttle blade itself is controlling the volume of air and fuel that flows through the carburetor. If I have air leaking in around these bushings because they don't seal right, then I'm drawing in an unmetered amount of air, meaning the throttle is set to allow a specific amount, and if I have extra leaking in around those bushings, it's going to throw off my ratio. And depending on where it's leaking, whether it's leaking into the throat of the carburetor above the butterfly, or it's leaking air into the bowl, or whatever it is, it can affect it in different ways, and this describes that. 49 says invert the casting, so flip it upside down, and then fill the area around the packing and those bushings with a liquid, and then blow with compressed air from the outside. If leaking is observed, replace the packings and retainers. A leaking or worn inner packing creates a lean condition. A leaking outer packing causes a rich condition. And in these pictures from the previous page, shows the position of where those would be. But essentially, with the throttle shaft installed, you put some liquid around there and then blow on it with compressed air. If I observe any of it leaking out to the inside here, then it of course isn't making a good seal. So checking packings for leakage is an important test process to accomplish, even if I haven't removed those bushings during my procedure, if they checked out and all that. So anyway, after the bushing installation, it talks about aligning and all of that, and where to use an O-ring if it's a turbocharged engine, how that differs from an NA. We're going to start on number 45. Assemble the pump idler lever to pump lever assembly with cotter pin. All right, that is this linkage right here, which is obviously dirty, but the two halves are joined here in the center with a cotter pin. During the disassembly process, to properly clean, you probably disassemble this by removing that cotter pin and throwing it away. To reassemble, slide this half over that, feed a cotter pin through, and then bend the tabs completely around. So you can see this isn't exactly correct. The tabs, or the legs of this cotter pin, are sticking outward. They should be wrapped back towards the head here so that they don't get snagged or bound up on anything. But you're putting those two halves together, which is already done here. 46, hold the pump lever in location. Very carefully slide throttle shaft through the bore and pump lever. Note, extreme care should be exercised to keep from damaging the packings during this installation. Lightly lubricating the shaft will help. Secure the pump lever in place in the flat provided on the throttle shaft with special screw. Okay, so they want us to start by installing the throttle shaft. All right, it should go in this direction where this threaded hole is, because that is where our idle stop screw is going to be placed. Let's see, make sure you guys can see. Okay, now to protect those bushings and packings, it talked about in the earlier steps from being damaged when I put this in there, it talks about adding a little bit of lubricating oil or other type of lubrication to the shaft so that it fits in a little bit easier and is less likely to damage any internal O-rings. So what I have to do in this step is to feed this throttle shaft in while also dropping this linkage down internally so that it lines up at the same time. Okay? Then once I feed the shaft through and it passes through this, then I have to orient it to where this flat right here fits onto this flat on the shaft. Okay? Just like so, and then tighten the screw down and torque it to the proper spec. So that's what I'm going to do. Just dangle it down in there, get it to line up. Okay, and there we are. We are in. Okay, now to get this lined up, we are going to move the throttle all the way to the idle position. So this big tab is lined up where that idle screw would be threaded in. And that should leave, hopefully you can see in there, that screw at that position. Okay, and it wants me to tighten it down until we reach between 10 and 12 inch-pounds. Okay, so I need to torque that. To do that, I have what's called a torque screwdriver. So it's a screwdriver that has a torque wrench feature in it. So I can set this to whatever inch-pounds I want. In this case, I want between 10 and 12. Okay, puts me at like 11 there. And then I just need to grab a bit to go on the end of it. Okay, I put together this little contraption here. Basically, has a 1/4 inch drive on the end. I've got a 1/4 inch drive socket, and then the appropriate bit on the end, which in this case, I can use a flat blade. Okay, you hear that click? We are at the proper torque. I had to get a little creative here because I couldn't find my bits for this torque screwdriver, but I just went ahead and put some tape to hold the bit from falling out since I had to hold it upside down. But anyway, that screw is now torqued in there at 11 inch-pounds, which is in our range between 10 and 12 that the book calls out for. So now that linkage should move with my throttle. All right, after we've done that, number 47, install throttle valve with screws. Tap the throttle valve lightly to seat it accurately in the bore with throttle closed. Tighten screws while throttle is closed. Torque them to 10 to 15 inch-pounds. Okay, so now we need to install the actual throttle blade itself. Okay, I'm going to feed this in here and then close the throttle to align it. Give it a tap so it seats itself down in there because I don't want it to bind up. So with it closed like that, and I've tapped it to get everything aligned, I'm going to go ahead and start the screws that hold it in. Make sure you get the right ones. The throttle screws are specific, as every other part in this carburetor pretty much is, but you can see how it's countersunk on the bottom to fit into the throttle shaft. I'm going to use my normal screwdriver to take them down to snug, and then I'll torque them with the torque screwdriver here in a second. Lightly snug them. Make sure it moves free and doesn't bind before I go through and torque it. And it does. See, everything aligns well. Okay, it says between 10 and 15. So my current setting of 11 is okay. I'm just going to go ahead and stick with that. Maybe I can show you in this example how this works. Okay, click. I like to go back and double check. Sometimes when you tighten multiple fasteners, it takes the tension off of one and needs retorqued, but these look okay. All right, that's torqued. Also says, note, certain carburetors do not use a wide open valve, and you may notice that the valve is limited up to 8 degrees before full open. This is normal and an important part of the throttle requirement. So it's saying if I open this throttle and it doesn't go straight up, say it sticks right there, see, not all the way open, it's saying some carburetors are designed to do that. And if that's the case, don't try to modify it to make it wide open. All right. Now it talks about that special testing procedures. Another one we need to do right here is 51. Safety peen throttle valve screws in place using peening tool 107 and arbor tool M100. All right, so now we need to safety those screws. If these throttle screws were to come out while the engine's running, it would take them into the engine, damage the valve, the pistons, and potentially cause a failure. So I need these to stay right where they're at. Now, you're going to have fuel running across this, so I guess they deemed thread locker or some intervention like that wouldn't be ideal. Instead, we're going to use a really simple process called peening. Basically, we're going to damage the exposed threads on the backside, basically mushroom out the screw that sticks through, so that if it tried to back out, the damaged threads would keep it from falling all the way out. So here's my M100 arbor that it's talking about. See, it's the same diameter round as the throttle bore, and it has a cutout that perfectly matches my throttle shaft right here. So that's going to go in and support all of that. I'm going to set it right here on the table. Oops. This throttle arm here is in the way. There we go. Okay, we're set up here on our arbor. This is our peening tool. So we are going to feed this down through the venturi, and we're going to place it on the end of the exposed screws that we just torqued in there. Okay? We're going to do that, and we're going to take a hammer and tap a couple of times to mushroom out those threads. As it says in there, 3 to 4 peen marks on edge of exposed screw threads should suffice. Do not over peen. So I'm going to place this in and just tap on the exposed threads around the edge. 1, in different positions. 2, 3, 4. and do that for the other screw. Okay, it doesn't take much. And I doubt you'll be able to see through the camera, but if you were to zoom in on that, you'd see that it is mushroomed out the edge of the thread slightly, making it much more difficult for these to back themselves out. Okay, at the end of step 51, it says, install throttle opening spring if used. So I'm going to grab this spring out of my bin, and I need to install it on this end of the throttle shaft correctly. Okay, you can see that the hole on the throttle shaft, there it is towards the outside, and the hole in the throttle body is towards the inside. So I need my spring oriented like this, where this inner hook is on the outside and this big hook here is on the inside. So I'm going to place that on. I'm going to lift this top tab and lock it in to the shaft, and then I'm going to wind this backwards so it's under tension. Oh, caught on my glove here. And go use the screwdriver so you guys can still see what's happening. Push it over top, and then make sure it locks into the hole, just like that. Okay. Just like that. Next page. 52 talks about installing the venturi if it was removed. Use extreme care. Note all Ma4-5 and 6AA carburetors use two-piece venturis. In that case, install the main venturi using the M512 tool. And install the primary with an M101, being careful to align the tang as shown. The 4-5 uses a one-piece venturi, meaning this inner one is made into the outer right here. They're not installed separately. If I did need to install that, if I had removed it, here is the M512 tool. See, it has these cutouts around the side. Those align with these pieces here, so it slides over that. And this big collar here bottoms out on the body when it's pressed all the way in. Basically, I'd mount this up on a flat surface, align my venturi, and then push it in. It's aligned by this one tab, so this stanchion or support for this inner venturi here, one of them is a little bit longer, and that has to be indexed into a cutout in the throttle body here. So if I align that, it'll be aligned for all these internal passages underneath it. But that's what it would look like there. Okay, 53, install bowl vent strainer, gasket, housing, flange, safety washer, and screws torqued to 15 to 20 inch-pounds. Note that the chamfer side of flange hole is against the casting. Okay, I'm going to flip this around and install my bowl vent strainer. So for that, I need the fasteners, the filter element, the safety washers, the retainer flange, the bell, and the gasket. Okay, so we're going to start by placing the filter element in its little cutout in the body. Then I'm going to take the gasket and place it over, aligning it with the two mounting holes. We'll then take this bell, which goes over top of that filter element, like that. And then I'm going to top it off with the flange. Now you got to look at this. You see how this side is chamfered, how that inner edge is round versus this side. See, it's just squared off. Okay, that rounded portion has to fit over top of this bell right here. So I want that rounded edge to be down against that bell. Once that's all set up, I take my two fasteners, making sure to align the gasket and get them started. Take your time here. It's easy to get everything in a bind, get it tipped, caught. So just take a second. Make sure everything feels right when it goes together. Now, I don't think these are the proper locking washers for this, but they will suffice for this demonstration. But again, if we were actually doing this, and like you should have done before you get to this point in my course, is go through the parts list and verify all the parts you have are for your specific carburetor. Okay, again, we're going to snug it up, take the torque screwdriver, and this says between 15 and 20, so I'm going to bump up the torque. That's 12, 13, 14, 15. Let's go to 16. You gotta be careful with these straight slots that you don't slip out, especially when torquing or loosening. There we go, there's one. Since these do have a hex head on it, I would suggest swapping over to a socket instead of relying on that flat blade attachment. There we go, we still got it. Both are torqued. And then finally, I want you to bend tabs to safety. Okay, so we're going to do the reverse of what we did when we disassembled. I'm going to take the edge of a screwdriver and bend a couple of the tabs up, tight against the head of the bolt. It's going to help me to get this arranged a little bit different. There we go. Now for this course, I don't want you to bend all of the tabs. It's kind of a waste of material and time to do that. Okay, because these are going to come apart again. It puts a lot more wear and tear on the carburetor when every tab is being bent every time. So, just as an example, see this bolt here, I bent that tab up tight, flat against the bolt head, and I've done one over here as well. Okay, you're going to do that for a couple of those tabs. That's bent, safetied, and secure. Now the bolt can't come loose. 55, install idle channel drill plug. That is this right here. If you have removed this screw, go ahead and reinstall it. I told my class not to remove that because of how often they get stripped out in this course, especially because it wants you to add Loctite to this and the pressure takeoff plugs. So install idle channel drill plug and pressure takeoff plug with Loctite 222 or equivalent, then torque to 12 to 16 inch-pounds and 25 to 30 inch-pounds respectively. So put Loctite 222 on this if you did remove it, and you're going to torque that between 12 and 16 inch-pounds. Install Loctite 222 or equivalent on these pressure takeoff plugs and install and torque between 25 and 30 inch-pounds. 56. Install pump idler lever screw and safety washer into casting and through pump idler lever. Tighten to 80 to 100 inch-pounds. All right, now we're continuing on with our linkage here by installing the bolt that it pivots on there. So that is this guy right here with this washer. This copper washer should have a flat on the bottom, which indexes with a flat on the body. Okay, and then inside the shaft, non-linkage. This hole right here should go into the bolt as I pass it through the body. So let me get that lined up. Make sure your washer is oriented correctly before you tighten this down. Okay. Like before, I'm going to snug it up. This is what it should look like before torquing. See how that washer is oriented? See how the linkage is on that bolt? Okay, now tighten to between 80 and 100 inch-pounds. Okay, this torque screwdriver only goes up to 36 inch-pounds. So for that, I'm going to have to grab a separate torque wrench. I'm going to stick right at the bottom, right at 80 inch-pounds there. This is a 9/16 socket. Okay, torque to 80. Once you hear that click. Then next, we're going to do the same and safety it by bending up a couple of these tabs to safety this bolt. Okay. The copper is really easy to bend. You really don't even need to tap it with a hammer if you know how to control your screwdriver. So just like that, I've bent every other one for a demonstration here. Tight and flat against the bolt, no way that can come out. Okay, tighten to 80 to 100, install washer and safety with cotter pin, bend ends all the way around, bend tabs for safety washer. All right, so on the inside here, I should have a flat washer like this that goes on the back side of that lever on that bolt right there before receiving cotter pin. Okay, you take your new cotter pin after putting the washer on, and feed it through the hole in that pin you just torqued. Okay, now it can be a little difficult to reach, but I like to take a smaller flat blade and start the bend on those legs of this cotter pin here. Kind of difficult doing this where maybe you can see and where I can see to actually do it, but okay, this is one of those things that's really difficult, so I went ahead and cheated and broke this bolt back loose so I could spin it around and make sure I got those tangs bent all the way on that cotter pin, and then I retorqued this. It is possible if I had like a pick or something to grab those ends to bend it around, but the way the hole ended up being lined up when it was torqued, my tools that I had wouldn't fit. So there's plenty of space there. It didn't put it in a bind to back this a half a turn to reach that, safety the cotter pin, and then retorque this bolt. So that's what I did. Okay. Install throttle stop screw and spring. So that is our idle speed screw. I have that right here. Washer goes over this screw and then goes into this threaded hole here where it can push on the throttle to set my idle. We are just going to roughly adjust this for now. We'll do the final adjustment once it's installed on the aircraft or test stand. Okay, loosely set up there. Good for now. Next, 58. Number 58, install idle needle retainer plate. When used on its gasket, insert 3 screws into safety washers and start screws. Okay, we're going to install our idle mixture screw, which some use a plate, some just screw right into the body. If yours uses a plate, then you should have a matching gasket that goes atop of it right there. Should then be able to align that with the hole. And then you should have 3 matching screws with washers. You need to make sure that these are installed correctly. We talked about this in the first video, but you see those 2 legs that stick down like that? They're made to catch on this plate, so they need to be down. The other 3 tabs that stick straight out, they are going to be bent up to safety the screw. Okay, so the 2 tabs that we just face down will lock into the plate. The other 2 will, or other 3 will face up to lock the bolt. I'll show you close up here in a second. But if you remember, all these were installed incorrectly when we disassembled the carburetor. So it's one of the things we're fixing now. These are tiny screws. My fat fingers are not having fun here, so I'm using a screwdriver to help me out. Okay, loosely started, but you can see what's going on here. How those 2 tabs we had face down, how they're supposed to lock into that plate and secure it. And then we'll bend the others up to secure the bolt. Okay, torque between 15 and 20 inch-pounds. So back to our driver here. We're still okay at our 16 we had set earlier. But for this, I need to go ahead and remove my flat attachment. Figure out what size socket I need. Appears to be 1/4 inch. This one at the top, it looks like I need to remove the screw. So if yours is out, wait till it's torqued before installing the mixture screw here. Get clearance. Okay, all 3 are torqued. Then your mixture screw, you need to set back to its base setting or where it was when you removed it, which I'm going to go with 1.5 turns out as a base. So run it all the way in until it lightly touches the bottom, and then 1/2 turn, 1 turn, 1.5. Then I'll bend my tabs to safety these bolts. Whoops, try not to scratch up the casting. I've bent a tab on each one to safety that. And I've set my mixture where it should roughly be. And it even says here in the book, back the idle needle out, 1.5 to 1 turn, and then tighten the 3 screws. torque to 15 to 20 inch-pounds, bend lock tabs to safety screws. So I'm a half turn past what they say. I'll go ahead and satisfy them and turn it back in a half turn. On model of altitude compensated carburetors, incorporate a cutoff valve in the throttle body idle channel. This valve is operated by a walking beam lever, which is part of the idle needle retainer plate. Assemble this type as shown in figure 13. So if you had like a back suction lever up here, that's also a part of that plate. That's what it's talking about. It says view figure 13 for that. So let's find figure 13. Okay, figure 13, if you have that type, gives you more insight into the stack up, how that's supposed to be assembled. Okay, 61, install idle needle spring, flat washer, and O-ring where used on idle needle and insert into casting. Lubricate lightly to install, approximate setting 1 to 1.5 turns from seat. Install idle needle spring 53. Okay. 62, place small end of air metering spring over small section of air metering pin. Insert this assembly into economizer jet. All right, so now it wants me to install my economizer. So should have 3 pieces. My spring is stuck inside here, but you have this needle, this housing, and then the spring that when assembled, make sure this springs to the, whoop, my glove is stuck in there, springs to the open position. There we go, like this. So it should spring open, nice and smooth, just like that. Okay, once you put that together, screw assembly into casting flush using M94. Okay, so I'm going to start putting this into my economizer channel. Then, okay, I'm going to take my M94 tool and run this in until this pin here in the center becomes flush. So we'll see what that looks like here. Flush doesn't mean that what I'm screwing in is flush with the housing here, because I still have to put a cap over it. It means when the needle inside becomes flush. And since there's a pin inside the center of this, when the needle is pushed out of the economizer, it pushes on this pin and moves it up and down so I can see it. So see how it's below level there? I'm going to keep going. I'm going to hold my throttle wide open while I do this. Keep running this in until I see that pin rise and become flush. And there it goes. Now it's risen up. That's a little too high. It's proud, so I'll push it back. That's roughly flush right there. Okay. And then now, then set the depth to the specific carburetor setting indicated on the service parts list. This is where that sheet that you got out of the parts finder is handy, because it had the economizer setting on the carburetor. That parts list says flush plus 1.5 turns. So flush is my starting position. Right here, that pin's flush. Now I'm going to count 1.5 turns past that. So it would help if I had a little mark, or I just have to be careful and remember where I'm at. I see the scribe that says this is the M94 tool is right over here. I'm going to match that. So I'm around. That's roughly 1 turn and then a half. Okay, now you can see that pin is protruding. But that is my economizer setting. That sets when the economizer will close, restricting air to my air bleed and making the engine run richer. So at what throttle setting does that engage, is basically what the depth sets. As it says here, the throttle must be full open when making these settings. An alternate procedure to set the economizer using a depth micrometer is as follows, and shows that in figure 9. So if I don't have access to an M94 tool, it gives me alternate dimensions, and I can use a depth micrometer to measure down into this hole to see exactly where it's at. Okay, after that, assemble air metering pen, jet, assembly into casting, open throttle valve to wide open, measure distance. Okay, that's what it's talking about with that alternate procedure. Let's continue. Okay, 63 talks about installing the cap to cover that up. You should have this plug with a two-sided washer. One side is metal, the other side is rubber. Yours shouldn't be dirty like this again, but rubber side goes towards the carburetor body, metal side goes out towards the head. And tighten in place and safety to casting through hole provided with wire. Torque to 5 to 10 inch-pounds. Okay, back to the screwdriver end. And we're going to back this off down to, let's split the difference and go to 8. 6, 7, 8. Okay, click. Then it wants you to add safety wire to safety this. I'll save all the safety wiring to the end. All right, install float bracket with screws. This right here, if not already installed. And torque in place 8 to 11 for those two tiny screws. Place horseshoe washer in its slot on the mixture control valve. Horseshoe washer should have been left in place by you guys right here. That's still there. And insert into its channel through washer number 35. Okay, let's look at our parts diagram here to verify we have all of that. 33, 35. Okay. So I'm missing some of the parts for the stack up here. So we're just going to have to do without for right now. Also, this is an area where the stack up may differ depending on carburetor type. So for this number 65, it says put the horseshoe washer in there, which we have, and then insert it through washer. So there should be a flat washer that goes over top of this horseshoe before I pass it up through here. I don't have that washer. Okay, install mixture control valve packing and thrust washer and spring on the top side. So once that's placed up through, then I should have a packing, thrust washer, which I've got an O-ring inside this piece here. That's going to seal it off. So I'm going to put that down in there. Then there should be a spring that goes under the head of this. Okay, unfortunately, both of the carburetors I've taken apart to use in these videos are missing that spring, but there should be a spring similar to what you had on your idle speed setting here that goes under here and keeps tension on that O-ring you put in to make sure it stays sealed. If you're missing that, let me know and I'll dig into a stash or we'll order some, but I don't have any right this second, so I'm going to go ahead and install this without it. I hate doing that, but that's what I have. Okay, after you put that spring on, then you need to put this clip into there, and then you're going to slide your mixture control lever over top, just like that. Okay, and remember that pin that inserts in the center keeps this from slipping even when the bolt is absent. That makes sure that we retain control of the mixture. Okay. Then we have our retainer bolt, which passes through all of that. May need to wiggle. Take your time here, don't force it. Want everything to fit together how it should. If anything's bound up, take the time to make adjustments or figure out exactly what's causing the issue. Okay. Packing thrust 67, turn mixture control valve until the locating holes align with the mixture control lever. Clamping slot, insert mixture control lock wire through lever slot and into hole in valve. Ensure the loop of wires towards the valve. Install the clamp screw through, safety washer, mixture control lever, and control lock wire. Okay. So we're going to snug that up. And we'll come back to that later. 68, install fuel strainer through safety washer and into casting. Oh, and you can see without that spring, you can tell there's something definitely wrong here. Okay, that spring is what keeps tension and keeps this pulled up where it's supposed to be. Now, depending on the side your strainer was in, it needs to go back in that location, because if you mix it up, you're going to find that your fitting does not line up with your fuel line. I'm going to place mine in here. Remember to have crush washer in there. This one should have one with legs, like we're going to see in a second. Actually, I don't have one of those either. If you see this tab on the throttle body, you should have a washer that has fingers coming off of it, a safety washer, just like we saw everywhere else. And those tabs should lock into that nub on the body and then be able to be bent over the head to safety this. Okay. Fortunately, again, this carburetor has seen some significantly poor maintenance and does not have all of its original components. Okay, so we've got the strainer in here. Tighten to 10 to 12 foot-pounds and bend tabs to safety. Okay, you're going to torque that just the same as we saw before. Now we're going to go to float valve, seat, and gasket. Here's the seat. This one again is dirty, but remember you should have a seal on the bottom here, which I can pop off still. Have that washer on the bottom. That needs to be there before you install this. Plus any shims that were there as well. But I'm going to install this and tighten to 10 to 12 foot-pounds as well. So let me grab a torque wrench to do all of those things. Okay, that torqued. And then since these fittings require the same torque, we'll do them at the same time. So those should be 10 to 12 foot-pounds. That's a much higher value than everything else we've torqued so far. Everything before has been inch-pounds, so way less. With these two and the seat, get a little bit more. Okay, place casting flange down on bench and install pump plunger. The tangs on the pump should slide through the elongated holes there. So yes, now we're putting our pump plunger back in. And feed it in and line it up with those tabs. And come on, work with me here. There we go. Place it from the inside, just like that. Place throttle body to bowl gasket in place on the casting. Okay. I want this to go on, get around the bracket, just like so. Exercise care during the following operation to prevent damage to the float. Install float, place the throttle body on bench with mounting flange down, install the float valve into valve seat, and install forked float valve retractor clip with the lines of the fork position under the head of the float valve as illustrated in figure 15. So this is kind of the delicate operation here. I need my float valve needle, put that into its seat. I need the retractor clip right here. I need my float and the pin that secures it. Okay. The forked end here catches under the head of that needle. Okay, just like that. And then we're going to slip our float in and then take the pin and feed it through all of those parts. Okay, make sure that retractor clip stays aligned. And then I'll help it through with the pliers because this one's still dirty. Just like so. So this is what I have. The float should be restricted by the tang on the bracket from dropping too far. And if you look there, you can see how the retractor clip is set up. And if I flip it around this way, you can see that retractor clip helps lift the needle or keeps it connected and moving with the float. Okay. And then of course, ensure the float shaft is free to rotate and the float valve and valve movements are not restricted between the fully open and fully closed. So it should move freely. It shouldn't be bound up or require any force. The float setting is established as shown in figure 17 with a 13/64 clearance between the float and gasket measured near the outer end of each float. So let me grab a 13/64 bit. Here's my 13/64 bit. I'm going to use the shank end, or the part that would go in the drill, and I want to verify that this bit hasn't been used before. It hasn't slipped in the chuck, thereby machining down its diameter. But with this setup, I want to place this on the gasket under the edge of the float, and I want it to just barely touch. Okay? I want to check it on both sides. And if I look here, I've got some issues. See, this side, it picks the float up. It's too tight. But this side, it's too big. So something has happened to my float, and if I look at it, I can see it's kind of bent and twisted up. So that's another reason why you got to be careful handling these, because somebody has mishandled this. They've caused this float to become twisted and damaged. You should not flex on the float as I am doing here. If you find one that is damaged, it's probably best to just replace it and not chance it. But this is how it should be now that I've tweaked that. Just barely touches, doesn't really lift the float, but there's no excess clearance either. So my float height is set. If you were to need to adjust it and your float wasn't twisted or damaged, this is where you'd make your adjustments to it. If you have the tab, like we talked about in class here, I could take a screwdriver and bend the tab either up or down to adjust the float height, or I could take the pin out, lift the float back out, take out the seat, and add or subtract shims to adjust it if my carburetor had that style. If all checks out, then you can install a cotter pin in the float shaft to secure it. So, same process as before. You need a new cotter pin. In my case, I'm just going to toss the old one back in. So I don't waste any supplies for the class. Just like everything else, it wants the tabs or the legs of this cotter pin to be bent all the way around so it doesn't stick out and catch on anything. Okay, secured. Place throttle lever at proper angle, location on throttle shaft, and secure with a retaining nut. All right, this is where, when we took it apart, you guys marked what angle this went to. Realign your marks, and then tighten down the nut that holds it, torque to 20 to 60 inch-pounds. Okay, let's see, it's gonna be smaller. 7/16, 20 to 60. Let's back this down. Already set to 50 here, so we'll just go ahead. Okay, let's try that. And it doesn't line up. So this is one where you're going to get a lot of experience. Our wrench is already out. I have to achieve the torque within the range they want while also aligning the holes for the cotter pin. Okay, took some trial and error, but we found a torque within the range that made this happy and lined up. And it only took a minute or two to do that. So it can be a little frustrating if you let it be frustrating, but just takes a second and you'll get it there. I've reused my old cotter pin, put it through and bent it over. So we are done with that step. Okay, install cotter pin. Note, carburetors without the throttle lever lock nut on the end of the throttle shaft must have the lever safety wired as shown in figure 19. If you have an older version that doesn't have just a nut and cotter pin on the end, and instead you have a bolt that clamps the lever on, it gives you another figure and shows you how they want you to safety that once that's installed. All right, so we should be done with the top half of the carburetor. Set that off to the side. Okay, on the bottom half, I want you to install the drain plug and channel plugs, this and this. Make sure no thread loop can get into any passage of the plug. All right, if you put any thread tape would be an example, or thread lube, basically to help seal these plugs when they go in. You usually want to stay back a thread or two from the end, because when you tighten this down, you don't want that to squeeze into the internal passages and then get picked up by your fuel and clog something down the line. So you got to use that carefully and keep it back from the end so it doesn't contaminate the inside of the carburetor. This plug and this I hadn't removed from here, so it's still installed. It's pretty straightforward. Basically, do as it says here, tighten them, and then safety as well. Something to note is this is a tapered pipe thread, so the thread increases in diameter the more you tighten it, so it seals. You don't want to cram this down. If you keep tightening and tightening this as hard as you can, you will basically hydraulic the casting apart and split or crack it. So no need to be that excessive. Just snug, is good on that. Install idle tube carefully, seat firmly, torque to 5 to 8 inch-pounds. For idle tube is this idle jet. Same process there. Run it in lightly with a screwdriver. It shouldn't bind or do anything. And then get a narrower bit than what we used earlier. Use a torque screwdriver or small torque wrench to tighten, torque to between 5 and 8 inch-pounds. Okay, then install pump inlet check valve assembly, and then torque to 10 to 15 inch-pounds. That's the assembly that goes down here in the bottom of the accelerator well. Older models use a ball safety ratchet against a knurled valve head as a safety. New models use a long lock nylon insert in the threads to safety. You can use the new style to replace all past production, but do not use the knurled head version in new castings, as no provision for safety exists. Okay, let's locate our check valve and we'll get that installed. Okay, here's our plug. Should have some ball bearings in it and a retainer to keep them from falling out. Just talking about with the knurls, if you had an older version, it'd have these ridges around the edge and like a ratchet for it to click into and lock so it didn't spin out. These newer ones, they don't require that. So it's just telling you to be careful of what style you have and that you can use this newer style in all carburetors, but don't use the older one that requires a ratchet in a new carburetor. So we'll try to drop that in there semi straight up and down, and then try to flip it around with my screwdriver so it's sitting the right way so I can try to get it started there. Sitting up how it should be. Take a big flat screwdriver and gently start the threads. If it feels like it's cross threading or it's binding up, back it off and try to realign. It should go in pretty easily. Okay, all the way to the bottom. Tighten to 10 to 15 inch-pounds. Okay, I can do that. We'll take our piece of tape. We fix the tip here, and we're still set within that range. Okay, that's torque. Install pump discharge check valve, spring if used, and tighten plug to between 20 and 25 inch-pounds. Okay, this uses the weighted style check valve. I'm going to go ahead and pull this back off here. Okay, this uses the weighted style check valve, which doesn't have a spring, so I just drop that in and then take the cap here for it and thread that in until it's snug, and then we'll go ahead and torque that. Okay. It says between 20 and 25, so I need to bump this up. Okay, and that's torqued as well. Some models incorporate a fuel baffle over the mixture metering valve. If so, slide baffle in place and secure with safety tab, washer, and screw. Yeah, so some of you have been wondering what this threaded hole is here. Some models will have like a shield that drops down over this and has a screw that holds that shield in. Most models do not. If you come across one in class, I'll help you navigate that. Okay, install lower gasket nozzle if used on shoulder at base of nozzle while holding the bowl inverted. Install nozzle and safety washer gasket, torque to 50 to 70 inch-pounds. Okay, that's the discharge nozzle here, which is placed back in here. Hold on. So with this, at the bottom you have this little washer on your discharge nozzle. That, if you have a new one, won't want to stay in place on the nozzle. So they're asking you to hold this upside down with that washer on the end and place this up into the carburetor for you to start the threads, so you don't give this washer a chance to fall off. Okay? And then you need your copper locking washer there as well. Okay, and then align the two tabs onto the lock. Run that down and then torque just like everything else we've been doing. All right. After that, once you safety the tabs on the discharge nozzle right there, we are ready to mate the two halves of the carburetor. When you put it together, you have to make sure that your mixture control goes down into the sleeve and that nothing binds up here. You'll place this together like so. I'm going to watch that as it feeds down in there. And I got to make sure the accelerator pump goes into its location as well. There we go. Okay, once that's done, you've verified everything is lined up, then go ahead and reinstall the two halves of the carburetor, those bolts and washers, making sure that the washers themselves lock into all these tabs around here. If you don't lock them in, they won't do a very good job at safety. Make sure you start all before you tighten any of them. Make sure you don't warp anything and that everything gets started nice and free. Once you have all those started, then go ahead and torque those to between 40 and 50 inch-pounds before bending the tabs to safety. After that, we're ready to test it out. Here's another check that needs to be done on the float before you do the final assembly of the two halves. You should take the cutaway portion right here. So it's a bowl that has been cut out for use as a tool. You're going to place this over, and it has alignment pins which line up with the bone holes. And it drops together. This way you can see how the float aligns when it's assembled. And you can see how close it is to the surrounding structure. Now the manual calls out for you to take a drill bit of, I don't remember the size off the top of my head, but you're going to pass it around the entirety of the floats, inside and out, on both sides, and make sure it doesn't interfere. If you can pass that bit around the entire float, then you know that it has sufficient clearance. If you can't fit the bit, adjustments will be needed. and that is where either the floats are bent or the tab that screws to the actual throttle body has some play in it, and it could have been screwed down at an angle, kicking the floats over to where they touch. So you may get some adjustment out of that. But you need to use the cutaway and check that before final assembly. Okay, here's an airworthy carburetor that I've taken out of its storage bag to show you what it should look like fully assembled and what your safety should look like as well. So for this economizer plug, you have to go through, move this out of the way, through the cap and up through this hole. A lot of people don't think you safety through this hole because it looks like, you know, your intake would mount here. Well, the intake only comes out to about that far. So this is exposed, allowing you to pass wire through. So you start your wire through there, come around, go through the plug, and have your pigtail out the side. Now on these, they like to take this chunk of lead and crimp it over top of the safety wire to keep it from fraying and coming loose, because you do get a lot of vibration from the engine through the carburetor. The drain plug, you can start by going through the plug itself and come up, and there should be a little hole drilled in the body there to create your pigtail. Older versions, these pressure takeoff plugs would have had a hex head with drills or holes drilled in them for safety wire, and you'd safety those two to each other. Also, older models may have a tab for the fittings to be safetied to the bowl as well, but again, depends on the model. But this is what a completed carburetor should look like. Should move free, open and close. Mixture should not be restricted and shouldn't have up and down slop. Everything should be safetied, cotter pinned, and all locking washers engaged in their tabs. Okay. That's what we're after.